All right, so now that we have a basic idea of the atom, the thing makes up everything around us, and also what the atoms themselves are made up of, let's take a look at how we classify matter. And then we're going to take a look, first of all, how we do that, generally based on the composition of the substance or the sample of matter that we're looking at. So when it comes to classifying matter this way, there are two broad categories that we're going to see initially, and then we're going to break these categories down into some subcategories. So the first thing we can say is matter can be either a pure substance or be a mixture of pure substances. So what's the difference between these two um, categories? Well, a pure substance itself is simply something that has the same composition or make itself. So there are two subcategories of those substances that we're going to see. And we've talked about one of these already. So you have things called elements. We introduced elements already, and we know that elements have the same composition, depending on what that element is. These are made up of only one type of atom. So it's a pure substance, in composition. And then the other type of pure substances that we're going to encounter, and these are probably more common than the pure elements, individual elements themselves. These are called compounds. And compounds are made up themselves of more than one type of atom combined in a fixed or definite ratio. Okay, I'll give you a couple examples of these just to illustrate the difference. So an element, we talked about these. So for example, like carbon made up of carbon atoms. You have iron, look at the iron atoms, you have sodium, made up of sodium atoms, etc. Well, in a compound, you have more than one type of atoms combined in a fixed ratio. So for example, I'm going to have different elements. So let's say hydrogen and oxygen in a 2-to-1 ratio between those atoms is nothing more than an H for hydrogen, and a 2 as a subscript tells us we have two hydrogens, and then an O for oxygen, and a subscript of 1. We don't usually put the 1 in, it's understood. H2O, and you probably know that is nothing more than water. So in this case, we have two different atoms, two different elements in that fixed ratio to give us H2O, right? That's a compound. That's a special type of compound. It's called a covalent compound. We could also have something, a compound in slightly different ways. For example, sodium and chlorine in a 1-to-1 ratio is nothing more than Na for sodium, Cl for chlorine. This is sodium chloride. That's regular old table salt. And that's another example of an ionic compound, which we'll see later on. So either way you slice it, these are made up of more than one type of atom, but they are combined in a fixed, unchanging ratio. So two hydrogens and an oxygen always is water. One sodium and one chlorine always is sodium chloride or table salt, right? So these are examples of pure substances. They have the same composition, same makeup, either elements, one type of atom, or compounds, multiple atoms combined in a fixed ratio. So pure substances are different than mixtures, and mixtures are simply instances where we have multiple pure substances that share the same physical space. We say multiple pure substances that share the same space, but they're not chemically combined. Okay, they're not actually stuck together with a chemical glue. In other words, they're not chemically. So under this general category, we have two subcategories, just like we did in the previous one. We have what are known as homogeneous mixtures, or sometimes you can write it homogeneous, but it's spelled that way. And then we have heterogeneous mixtures. Okay, so these are examples of mixtures. What's the difference between them? Well, it has to do with the uniformity of that mixture. So homogeneous mixture is uniform throughout. It looks the same, the composition is the same from one part of the sample to another. Okay, so for instance, if I had something like a glass of water, so there's an H2O, and I added a pinch of salt to it, and I stirred that salt up, right? You will see that the salt dissolves, and then that becomes a salt water mixture. And as long as all of the salt is dissolved, okay, that means that it's dissolved uniformly. That's considered a homogeneous mixture. The components are not actually chemically combined. They just share the same physical space, which in this case is just the beaker or the glass or whatever it is. Another example that may be sort of not obvious or counterintuitive is the air that you're breathing in right now. Air is a homogeneous mixture, and it's a homogeneous mixture of gases. It's distributed in the same proportion, whether it's the air I'm breathing in here or on the other side of the room. The proportion is going to be the same of these different gases, but the gases are not chemically combined, right? So the gases that you find in normal air would be things like nitrogen gas, which makes up about 78%. Nitrogen gas is N2. Oxygen gas, which is O2, makes up about 21% of the air that you're breathing in, and then a little bit of carbon dioxide that everybody knows they're breathing in, right? And that's CO2. So wherever you sample the air, right, you're going to get the same mixture, the same proportion of these different gases. They just share the same physical space, whether it's the space in the room or the space in a car, wherever, space in the atmosphere. And they're not chemically combined, right? So the nitrogen is separated from the oxygen, separated from the carbon dioxide, etc. That's homogeneous. Heterogeneous, as you can maybe guess, is a mixture in which the composition is not the same. So it's not uniform throughout the entire thing. So one part of it, of the mixture, or one part of the mixture may look different than another part. So as a very simple example of this, if you, let's say you went to your favorite pizza place and you bought a pepperoni pizza, right? So galaxies on here, And then you'll see that on that pepperoni pizza, maybe one slice has, let's do the pepperoni, right? One, maybe two, maybe a slice of pepperoni there, maybe on this one we got one. Maybe here we have one, here's a half of one, another one, maybe got four of them. Right, so my point here is that whether you take the slice on the left, so like this one, versus this slice over there, the composition, right, is not the same. In one slice, you have two pepperonis, and one you have one pepperoni. And these things are not chemically combined, right? They share the same physical space. You have the cheese, pepperoni, the dough, etc. So it's a mixture, first of all, but it's not uniform. So it's a heterogeneous mixture, right? And that's the main difference between mixtures of pure substances, right? The uniformity of the components. And then we also saw pure substances that have the same composition throughout, same makeup throughout. And specifically now we're looking at elements made up of just one type of atom, or compounds that have multiple atoms, but they are combined in a fixed ratio. So that's one way to classify matter based on the composition of the sample. Another way that we'll look at to classify matter is based on the particles themselves, and specifically how those particles are arranged.